Hello, can you hear me? Whoever's there. Wait a little while for some more people to join the stream. Hi Lila, how are you doing? Can you hear me? Yay, okay, good. This is the first one of these I've done where I managed to start off with sound. So yeah, I usually spend the first 5 minutes trying to figure out how to get it all working. But yeah, I think we'll wait for a few people to join. But yeah, how are you doing, Lila? Like, what brings you here? Are you doing your GCSEs like in January? Not in January, in June probably. Hi, Mikhail. I recognise you. You were here the last couple of weeks, weren't you? I'm actually starting with sound this week. You're doing your GCSEs next year. Oh, that's great. You're getting ahead, Lila. It's a really good idea. You can't hear me, Chile? I thought I'd got sound working for the first time. I've been told I'm audible. Everyone let me know if I'm not. Okay, yeah, Mikhail, you can. Shall I maybe try turning it up? It sounds like from me that's the only thing I can think of. Maybe someone in chat can think of what might be causing Chelai's audio not to be working. Okay, so yeah, I was just saying that usually these first 5 minutes are me just trying to figure out how to get my sound working. So I guess I can actually use this time to get to know you all. And you can also ask any questions you want about me. We'll wait to start the actual math for a few minutes, so we can get a few more people who might want to be joining. So yeah, so what's bringing you all to these math scores? Lila was saying that she's doing her GCSEs next year and getting a head start. Have lots of you got exams coming up? Are you finding the maths harder in classes? Riham, will we be doing histograms? I can tell you, I don't think they're on the lists of topics for these 10 weeks. However, if it is something that you want to do in the future, there's a little feedback link. And it'll be really good if you add it in there, whatever topics would be useful going forward. We can definitely do them in the future. July, you're doing your GCSEs in 3 months. Okay, good luck. I'm sure there's lots of people in that situation. I tutor maths and I have lots of students in the same position and it's very stressful for them. But yeah, I'm hoping that these sessions will be useful for you. I noticed that this isn't your first time here, Chile, so I'm hoping the fact that you're returning means you are finding them useful. Yeah, Riham, you're the same. I have a feeling a lot of people watching these will have their GCSEs coming up. I think it's great that there's some people here who are getting a head start as well and just keeping on top of the maths in year 10. You're finding it useful. Great. That's great. I'm glad to hear it. Are you watching any of the others, Chelai, by any chance? Or any of you? Are you watching the chemistry ones or the computer science ones? You probably can tell that I'm not the best with computers, so I have been watching the computer science ones to try and learn something. Yeah, they've been really interesting. But I'm sure they're even more useful if you're actually doing exams in them. You're homeschooled. Okay, I actually had a student who's just done his January exams who was homeschooling. It's quite intense homeschooling. It's quite hard to keep self-motivated. So well done for being proactive and finding your resources on YouTube and everything. You're watching all of them, Mikhail? Yeah, I think that's a great idea. I would be doing the same if it was me doing my GCSEs right now. And yeah. Okay, we actually have quite a few viewers. I think it's a good time to get going. So today we're going to be doing direct and inverse proportion. And how do you all feel about that as a topic? I know I ask that every week, but it's just useful for me to see how people are feeling about the topic before going in. Like, are people generally quite confident about direct inverse proportion? Or is it something that I think will be quite useful to get a bit of more of a refresher on if you haven't done it in a while? Or maybe you just didn't really quite get it when you went through it in class. Or other option is you've not done it at all yet, which is very possible for quite a few of you. Hi, Ciara. Again, it's really nice to see so many of you returning. Yeah, it's really, really great to see you all again. And hi, Olivia. So yeah, let me know how you find this topic. I'm going to get the whiteboard up. We'll have a look at some questions. We're just going to look at some exam style questions of these. Okay, so you understand it just a bit. Some people may find it quite easy. It's one of those things, isn't it? It's all about how you felt when you first learned it. So let me just get, which one was it? Oh no, this is where the grandma in me comes out and I get confused. Here it is. Right? Yeah. Okay, so yeah, no, it all depends on when you first learn it, how confident you feel probably. But we're going to go through it from scratch. So hopefully I'll be able to give you some methods for approaching these and make it a bit easier when you come across these questions. So I'm going to use the first two questions to really explain what we mean by directly proportional, inversely proportional. So first of all, this question here, we're told that A is directly proportional to B. The value of A is 7 when B is 28. And we want to calculate the value of A when B equals 12. Okay, great. I can see some people having a go at answering. I'd say everyone have a go. Put it in the chat box over here. And I am looking at them. And I want you to compare your answers to mine at the end. And just so that anyone who's newer to the topic, we can go through it. If you don't know, that's completely fine as well. So, A is directly proportional to B. First of all, what this means. So if it's directly proportional, it means that as we're doubling A, we're doubling B. If we're tripling A, we're tripling B. So they go up together at the same time. If we were to draw this on a graph of anything that's directly proportional, so we had a graph like this, both A and B will be 0 at the same time. So if A is 0, B is 0. So in other words, it will pass through the origin. And they will go up together in the same increments. So in other words, it's going to be a straight line. What the gradient of that line is can vary, but this is really what we mean by directly proportional. They have a direct relationship. And yeah, if we double one, we double the other. We triple one, we triple the other. We quadruple one, we quadruple the other. This graph actually is very useful to remember for your sciences. And this is how you can describe graphs as well. If they are straight line and pass through 0, you can use directly proportional to describe that graph fully and you'll get all the marks. So that's the first thing, like what it actually means. In maths, equation-wise, what we're going to be writing is we can use this funny symbol. So we can say A is directly proportional, and this is the symbol we use for directly proportional to B. And then this isn't easy to use if we want to rearrange. We usually like to have equal signs, not things that are so ambiguous, I guess, or specific to direct proportion. So instead we like to write A equals some number, it could be any number at all, just a constant, times B. So K is just a number. And this is the general form for anything that's directly proportional. So for all of these questions, if we say directly proportional, it means equal to K times the thing it's proportional to. So let's get rid of that. Okay, so for this specific example, notice that they give us a pair of values for both A and B to start with. And we can use this pair of values that we already know to find what K is. Once we know what K is, we can then stick it into our equation and calculate the new value we're trying to work out. So for this one, we're told that A equals 7 when B is 28. So we can substitute these in. So we can say when A is 7, we can replace the A with a 7. K we don't know yet, times B, which is 28. So like this. So we can rearrange this to find what K is. We want to move the 28 over to the other side. At the moment it's multiplied, so to get rid of it we want to divide. So that means that K is going to equal 7 over 28. 7 and 28. 7 is a factor of 28, so we can divide top and bottom by 7. So K equals 1/4. So that's step 1. We found what K equals. That means if we go back and put this into our equation over here, that means that A equals 1/4 of B. Is everyone happy with this? I'm not going to wait too long because I think there is always that little bit of a lag. However, I will keep my eye on the chat, so if anyone has any questions, type away. If you're happy also, just say you're happy. So this is where we get to, and now we can say what does A equal when B equals 12. So we can say A equals 1/4 times 12, which is going to be 3. So this was a quite simple example just to show you what direct proportion is, how we work with it. So A equals 3 is perfect, just one perfect. Okay, good. So that's our direct proportion to start with. And then next we can go on to the other part of this topic, which is inverse proportion. Is this the way we'd always work out questions like this? Yeah, basically, if you have a pair of values for the ones in the equation, your first step is to work out K, like what your proportionality constant is, and then use that afterwards, because then you'll have like a complete equation that you can just plug in the value of whatever the unknowns are. So in this example, we have a pair of values for both C and D. So we're first going to find K, then afterwards we're going to plug C into the new equation to find D. So here, inversely proportional means we're going to have a slightly different equation to start with. Inversely proportional means that C is directly proportional to 1 over D. So that's the only difference between inverse and direct proportion, is this 1 over. So we can plug in, well actually first of all, let's turn this into a proper equation. So turn our proportional sign into an equal sign. And just like the one before, because we've already now got it in a directly proportional format, we just say this is equal to K, some constant, times 1 over D. Or we could squish these together and just say K over D. Now we've got our equation, we can go back, use the pair of values in this equation to find K. So all of you have a go at finding K, type in the chat what you get. So what I get here is I'm going to substitute in 2.5 for C equals K, which we're working out, divided by 15. We want to rearrange. At the moment, the K is divided by the 15. We want to move it to the other side. So we're going to times both sides by 15, which will give us K equals 2.5 times 15. Which is 37.5. Why do you use K in the equation? To be honest, it's just like standard notation that people tend to use for the constant. However, it's not necessary to use K as the letter. You could choose whatever letter you like there. The important thing is that no matter what values of C or D you plug in, K is always the same. So yeah, if you want to call K A or X or whatever, doesn't really matter, as long as you're consistent. Daniela, you're completely right. It's 37.5. Okay, good. So we've got what K is. Now we go back to the original equation. So our equation, we can now rewrite with what K actually equals. So K actually equals 37.5 over D. And now we just substitute in the values we know. I'm going to do it over here just so that we still have all the working on one page. We are told that C equals 8. So you replace the C with the 8 equals 37.5 over D. You want to rearrange this to find D. Probably best to first put D up to the other side so you get rid of it from the fraction. So then we can say that 8D equals 37.5 and therefore D equals 37.5 over 8. So if you plug that in your calculators, see what you get. When I put it in, I got 4.6875. But they want this to 3 significant figures. So I'm going to round this up to the third figure. So 1, 2, 3. I've got a 7 after the 8, so it's going to round up. 4.69. Yeah, it would round up to 5 if it was asking to the nearest whole number. However, here they were saying 3 significant figures, so you want to use those first 3 numbers from your answer. What is D? We're not actually told here. D could be anything. It could be like the number of dots in a square or something is proportional to, inversely proportional to, I don't know, the size of the circle maybe? No, that would be directly. Something like that. But yeah, so D could be literally anything. In some questions, it might actually have a physical value. But here, it's just a letter in algebra. Okay. Yeah, is everyone happy again? Is everyone with me? These are the 2 simplest examples, probably. And it's just to demonstrate what the difference between direct and inverse proportion is. So just like to quickly recap, direct proportional, we write A is directly proportional to B, and we just stick a multiplication of K in front of B when we put the equal sign in. Inverse proportion, we do 1 over the thing it's inversely proportional to, and once we've done that, we can carry on like the one before. Put K in front of the 1 over thing. Okay, again, any questions, put them in chat. I will get to them and answer them. But let's just take it up a step. So we're not always just going to be directly or inversely proportional to those numbers exactly. We could be doing things to those numbers before. How many marks will this be? Okay, that's a good question. For these ones over here, I'd say they're probably like 2-mark questions. 1 mark for finding K, and then 1 mark for using that to find D. Would this be in the foundation paper? Yes. It would be in both higher and foundation. It's just that, again, it might depend on your mark scheme, so you may double check, or your syllabus, I mean. So double check your syllabus to know for sure. However, most of the time this is in both. It's just the higher paper questions could go up a few levels of difficulty compared to the foundation paper questions on it. Okay, so let's go on to the next type of question on this. So here, Z is inversely proportional to the positive square root of Y. And then we're told a pair of values for Z and Y, and we're asked to calculate the value of Z when Y is 25. One thing to notice here, exam technique-wise, not specific to direct inverse proportion, is that they're asking for it in exact form. What that means is don't put it in your calculator and round it to any decimal places. Instead, keep any fractions and keep any surds. In other words, keep any root signs in there. Don't round it to any decimal places. Okay, so first of all, let's go back to the beginning of the question. So we're saying Z, so we can start that, is inversely proportional. Remember, for inversely proportional, we're going to put our proportional sign and then it's going to be 1 over the thing it's inversely proportional to, the positive square root of y. So instead of putting y under here, we're going to put the square root of y. And then we carry on like before. So this is really only the next level of difficulty of it. Be aware, don't just rush to do z is directly proportional to 1 over y. Always go back, maybe go through with a highlighter when you read the question for what it's actually proportional or inversely proportional to. But yeah, otherwise the steps are the same. So we can now substitute in our values of z and y. So z is 10. Oh wait, no, sorry. First of all, let's do an equation. So this means that z is equal to k times 1 over square root y. And now we're going to substitute in our values. So z equals 10. We can replace the z with a 10. We don't know k yet, so we'll just leave that here. Times the square root, 1 over the square root of 3. And we're not going to put the root 3 on our calculators because we want it in exact form. So we want to keep any root signs in there. So now we want to rearrange this. We can times both sides by root 3. So we'll end up with 10 root 3 equals k. And that's our first step. What this means is that our final equation over here is z equals 10 root 3 over square root of y. And yeah, there's our equation. So we've got that. Let's now put in what value we have for y to find out what z is. So when y equals 25, what happens? So z is going to equal 10 square root 3 divided by square root of 25. Square root of 25. Again, everyone sort of put into chat what you get at the end of this. Compare your answers to what you get here. So square root of 25 is just 5. And now we can simplify this. 10 over 5 is 2, so the numbers will just change to a 2, square root 3. And that will be your answer. And, oh, I just realised you can't quite see because where I cut the page. So I'll just move it over slightly. So there's your answer. 2 root 3, exactly, Dave. And Finn, perfect. I'm glad to see that people are following this and that you're getting the same answer as me as well. Again, ask any questions as you go. These questions, once you know the method, they become a lot easier. You're doing the same thing every time. So let's go on to the next one. The cube of x is directly proportional to the square of y. So again, notice this time we're doing things to the x and y before we're saying about them being directly proportional. So we just want to put these. Why is it called direct and inverse proportional? It's a really good question. So my understanding of it, I don't know if there's any linguists in here who are better, but if we're saying it's direct proportional, we're saying there's like a direct relation between them. In other words, they both go up and down together at the same rate. So as you double one, you double the other, so on. Inverse, in maths, usually when we say inverse, we mean 1 over. So that's why. Okay, so let's just set this question out. So the cube of x, so x cubed, is directly proportional, so we're going to use our direct proportion sign, to the square of y, so y squared. And then we just do what we did before. We're going to say x cubed equals ky squared. And now we can put our values in, find what k is. So everyone have a go at this again, put in chat what you get. I'll work it out on the page so you can follow along as well. Why x cubed? So in the question, they're telling us the cube of x. So that's why the cube, just read the question, follow what they say in your equation. This is why for these, that's kind of the trickiest part of these, that people slip up. I would say just go through when you're in the exam with a highlighter or underline as you go. But yeah, so that's why it's cubed. And let's substitute in the values. So when x is 2, we're going to have 2 cubed times k times y squared, which is 8 squared. So 2 cubed is 8. 8 squared, 64. Okay. Okay, so we can rearrange this. We can bring the 64 over to the other side. We're going to divide because at the moment it's times by the k. So we can say k equals 8 over 64. Both are divisible by 8, so we can say that's just the same as 1 over 8. Which means we can rewrite our equation to say x cubed equals 1 over 8 y squared. Okay, so got our equation. We just do the same as before. So we can say that when x equals 4, we're going to have 4 cubed equals 1 over 8 y squared. We're trying to find y, so we're going to 4 cubed, 64, times 8 equals y squared. So this is where you're going to need your calculator, because we're kind of going into the calculator paper region here. So if we want to do this, what we're going to get is that y squared equals 512, which means y. Exactly, Chile. I'm glad to see you're following. It's perfect. And this is actually a funny one. A lot of the time, the mark scheme will be quite generous for GCSE. However, when you square root a number, you actually always have 2 solutions. And this is why it says possible values instead of possible value. Because whenever we square root a number, you're going to have a positive and negative root. Like if you square root 4, 2 squared equals 4, but also minus 2 squared is also 4. So here, when you square root this, technically, you should always do a positive and negative solution. So 5, 1, 2. So when you do this, you're going to get plus and minus 22.6127, so on. Okay, good. I'm seeing like lots of answers here. So 16 root 2, actually, that probably is completely correct. I was going to do it, they're saying 3 significant figures, so I've calculated it to decimal places. So I'm looking at the first 1, 2, 3. I'm looking at the number after the 6, which is a 1, which means it's going to be 22.6. Mikhail, you were completely right about it being 23. It's just here they were asking for 3 significant figures, which is just why I did it to that degree of accuracy. And yeah, Nathan, you're completely correct as well. Good. So they're your standard questions. We only want these sessions are only half an hour, but I think we could do one more. So let's do this one just to finish up on. So again, all have a go at this. Compare your answers at the end. So positive square root of x, so square root of x, is inversely proportional, so proportional to 1 over, the cube root of y. Cube root of y, so we put a little 3 here to show it's the cube root. When x equals 16, y equals 125. So, first of all, root x equals k times 1 over the cube root of 125. Oh, wait. I'm getting ahead of myself. Over the cube root of y, and then we can plug in the values. So let's just put the values in. So root 16 equals k times 1 over, so we could just put 1 over, cube root of 125. I move down the page here slightly. Okay, so that means 4 is going to be equal to k over cube root of 125. The first cube numbers are actually quite good to know, up to 125. So the cube root of this is actually just 5 itself, and that could come up in a calculator paper. So that's just going to be k over 5, which means that k is going to be equal to 20, because we can times up by the 5. Same method as before, now we've got k is, we can re-put that into our equation, say that root x equals 20 over the cube root of y, plug in our value for x here, so the square root of 9 equals 20 over the cube root of y. Um, 15 root 5. Cube root, so yeah, just 5 here. So 5 times 5 is 25, times 5 again is 125. Good number to just remember, to be honest. Cube numbers of 2, 3, 4, and 5 are like really good to remember for your calculator paper. But yeah, so we can rearrange this. So the square root of 9 is just going to be 3. So we can rearrange this to say that the cube root of y, so if we bring that up to the other side, and then we can divide across by the 3, is going to be 20 over 3. Which means that we can just cube this number over here. So that should be that y is going to equal 296 to 3 significant figures. So those are just some examples. These come up a lot in exams. The method is always the same, so once you're happy with this method, these can actually be relatively easy marks. You just got to be careful of reading the question carefully. And yeah, so we'll leave it there. I'll go back to, like, we have to talk to you a bit better. I hope you all found it useful. Let me know if you did or not. And next week, what we will be doing are angles in parallel lines. So join us next week if angle stuff is something that you always dread. Or if it's something you've not done yet or need a refresher, be at 5 p.m. again. Hope to see you all there. And yeah. Thank you today. I'm glad it helped. Manu says, yep, I remember from last time you saying that. My brother would disagree, but I'm not going to get involved. No worries. I'm glad you all found it helpful. I'm going to disappear. I will see you all next week. Like I said, always nice to see that there are so many familiar names over here. So please come back. It's nice to see you all. And have a lovely week. Bye.